All right, let's finish up this year pretty strong. Today would be the 29th is when you're watching it, or the 30th, depending on what day you're going to do that. But we're going to look at today, just like yesterday. When we go and integrate, we're not going to need the C, because when I go and use the fundamental theorem of calculus, if I have plus 2 and then I go and subtract away 2, that would be my C. It's going to disappear. Okay, so evaluate what happens after I get my antiderivative, plug in upper, lower, subtract those, you can get your answer. Okay, so if I knew that I was looking at trying to integrate from 0 to 3 of this function d of x, that's going to tell me, well, my antiderivative would just be 8x plus c. But again, when I go and plug in 3 and I go and plug in 0, that part's not going to matter. I'm going to have 8 times 3, which is going to be 24, and then 8 times 0, which is 0. So I'm going to be subtracting what happens at where I stop minus where I start. So 24 minus 0 would say my answer there is 24. That is the area from 0 to 3 underneath that line. If I went and looked at from 1 to 9 of 8x to the third, well, again, that's going to tell me integrate. So make sure I add 1 and then divide by my new exponent. That's going to make that 2x to the fourth. So up until this point, right, my antiderivative would be 2x plus 4, 2x to the fourth plus c. But when I go and use this part there, that c part would cancel out. So I don't really care about that. If I go and plug in 9 and I plug in 1, so I'm going to have 2 times 9 to the fourth, which that should be, so 9 to the fourth times 2, that's going to be 13,122. And then if I go and plug in 1, that's just going to end up being 2 times 1 to the fourth, or just 2. So again, upper minus lower, right? And then go and use those two values. 13,122 minus 2 says 13,120. And that is my area from that stop to that start. If I had one that looked like this, okay, if you can multiply, do that to make it easier to integrate. Don't try and integrate this part and that part. That's going to go and throw everything off, so just be careful with that. If I go and multiply through, that's going to make that 6x squared minus 12x. And now integrate both of those pieces. So I already have the 6 there. If I add 1 and then divide by that, that's going to make that 2x to the third minus, again, add 1, that makes that 2, and then divide by that. So what I'm going to be using as my antiderivative, and again, that is my antiderivative, that 2x to the third minus 6x squared plus c, and then plug in my values, 2 and 0. What's nice about this is 2 times 0 to the third minus 6 times 0 to the second is just going to be 0. So f of 0 is just 0. If I go and plug in 2, that's going to be 2 times 2 to the third minus 6 times 2 to the second. So 8, so 16 minus 24 should be negative 8. So negative 8 minus 0 says my value there is going to be negative 8. That's my area from the stop to the start. If I had one like this, again, rewrite it. I'm going to call that x to the 1/4. That's going to say add 1, which makes that, and a fast way to do that is just add that to the top, because adding 1 is the same thing as 4 over 4. So if you just look at your bottom, right, 4, add that to the top. If it had been 1/7, I'd be adding 7. Just makes it a little easier to go and get those. And then make sure I multiply by the reciprocal. So that's going to be 4/5. And again, that is my antiderivative. I'm going to plug in 16. I'm going to plug in 1. So 4/5 times 16 to the 5/4. And then if I go and plug in 1, oops, if I go and plug in 1, that's going to be 1 to the 5/4. So when I plug in 1, that's just going to give me 4/5. And then if I go and plug in 16, the 4th root of 16 is 2. 2 to the 5th power would be 32. 32 times 4. That's going to make that 128/5. So 128/5 minus 4/5 makes that 124/5. And I know that's not going to simplify because 5 does not go into a number that doesn't end in a 5 or 0. So 124/5 would be that final answer. If I had one that is fraction, rewrite it. So if I go and add 1, that's going to make that to -2nd, and then divide by what I have. So it's going to make that my antiderivative as -1 over x squared. So if I have -1 over x squared, I'm going to go and plug in 4, and I'm going to plug in 1. Well, if I plug in 4, that just says -1 over 16. So I'm going to have -1 over 16 minus, if I plug in 1, that just gives me -1. So if that's -1, so minus, and that's a -1, that's going to say really add 1. So 1 is 16 over 16. So 15 over 16 would be that area. If I had one that looked like this, from 1 to 9 of x minus 2 divided by the square root of x, again, don't try and do like, oh, I could try and do reverse quotient rule. That's not going to help you. Okay. On this one, I'm going to rewrite that. This is really x over x to the 1/2 minus 2 over x to the 1/2. Take that one fraction and split up into 2. Now I have division, which says subtract those exponents. And again, right now, this is me just rewriting the integral. I have not taken any antiderivatives yet, just rewriting what I have. So then if I go and add 1, that's going to make that x to the 3/2, which says make sure I put that 2/3 out in front. And then if I go and look at the other parts, I would have add 1, that's going to make that -2 times x to the 1/2 times 2. So I'm really trying to look at my antiderivative of 2/3 x to the 3/2 minus 4. And then the square root of x. So again, I'm going to use 9 and 1. So if I go and plug in 9 up here, the square root of 9 would be 3. 3 to the 3rd would be 27, which really just gives me 18 there. And if I go and plug in 9, square root of 9 is 3. 3 times 4 would be -12. So that says that my value for f of 9 is really 6. If I go and plug in 1, I'm going to get some nice fractions here. So if I plug in 1, I just get 2/3. And if I plug in 1 there, I have -4. So again, need to go and change this. That's really 2 over 3 minus 12 over 3. So it's going to make that 10 over 3. So if I go and subtract those, that's going to get me to 8/3. Because this is really 18 over 3. So 18 over 3 minus 10 over 3 would be 8 over 3. And then on the last one, if I go and look at what I have, if I integrate, that's going to tell me add 1 and then divide by that new exponent. So divide by 3 minus 4x squared, divide by 2, and plus 2. And if it had just asked me for what is my antiderivative, that is where I'd stop. but that's not what it asked me for. It says now evaluate what happens at 1 and what happens at -2. So if I go and plug in 1, 1 to the third is 1, so I get 3, minus plug in 1, 2 times 1 squared would be 2. The c I don't really care about. So f of 1 is 1. If I go and plug in -2, that's going to say -2 to the third power, -8. -8 times 3 would be -24. And if I plug in -2, -2 squared is 4. 4 times -2 would be -8. So that's going to equal -32. So -32. So f of -2, so minus -32. And if I'm going to put those together, that's going to tell me my final answer there should be 33. Okay. So again, we're still using antiderivatives, except now we just have values to go back and plug in. So for, so Wednesday, Thursday, you guys have time to work on this. This will be due Thursday by midnight. So you guys will have plenty of time to work on that. If you have any questions, don't forget to come and talk to me through an email, whatever you need. Hope you guys are doing okay. Talk to you guys later. Bye.